Hi everyone, and welcome back to my channel. Today I'm going to show you how to use sine and cosine to make a circle. Really, how does sine and cosine make a circle, not how to make a circle, but why do they work? I've made another video previously that showed you how to make a circle using sine and cosine, and while that's great and all, it doesn't really give you any background or any insight as to why it works, why two sine or two waves like you see on my chart here, the green sine wave or the green cosine wave and the dark blue sine wave, how can that make a circle? So in the previous video we used the sine wave to generate our y positions as we stepped in different radians around the circle, and the cosine to make the x. But why does that work? How can we show in a better way how using each of those steps to make a combined xy coordinate that traverses the circumference of a circle? So I made this video here showing a sine wave and a cosine wave, not just a circle. And what we're going to do is take a few steps to show you how we can make the sine wave make up the y components of a circle and the cosine make up the x components of a circle, and then how that actually allows you to plot it. So when you first look at this, you don't see much. Like, it doesn't look like a circle as is. It looks like two waves that fluctuate up and down, and you're right. So what I've done is I've made a way to show the x in a manner that really represents graphically the component of a circle that it makes up. And I'm going to do that by transposing this cosine wave to have its varying values here go left and right across the x-axis of my chart, while leaving the sine wave going up and down on the y-axis. And just to make it easier to see the values, I'm also going to at the same time shift them to the 0 coordinate. That'll be the 0, 0 coordinate. That'll be the origin of our circle. So as I do this transposition, you're going to see this first value of cosine, it's now going to be down here, and as the radians increase, as we see the sine wave or the cosine wave step through each radian, it's going to look something like that. So let's go ahead and take a look what that does. I'm going to shift it to the origin at the same time. I'm just scooting the sine wave over and transposing the cosine wave. I did it in 20 steps so you could follow it there. Let me show you one more time what that looks like. Watch as this first at radians 0, what that value, where that value goes. It's down here at the bottom. So I've made my amplitude of my sine wave pi, and we're doing a 2 pi radian time element, if you will, here. So as we step through what makes up a circle, this very bottom right, which is really our first coordinate of our transposed cosine wave, is the first in the series, and as we go step through each of the radians, it will traverse up this way. The very first sine coordinate is about here, and it will traverse this way. So what we can do is now for our cosine wave, since it's going to handle the x-axis values of our circle, is I'm going to plot a vertical line at the point that we step through on our cosine wave at each one of those, and it will go all the way up and down on my chart. I'll do the same in a horizontal with a horizontal line for the sine wave, and it will always traverse this way. So if we see wherever the intersection point of that vertical for the cosine wave and where the horizontal is for the sine wave, that is the point that we're going to use to draw our circle. And that's really the same that we did in the previous video where we did the cosine of x, or the cosine of the radians is going to be our x value, and our sine of the radians is going to be our y value. So let me go ahead and turn on my vertical and my horizontal crosshairs so we can see where we're at. So on this very first point of the cosine wave that we transposed, and this very first point of the sine wave that we scooted over to the to line up and have 0 as our origin, that puts our crosshair right here at 3.14. I told you our amplitude was 3.14, so that's how far we should be from the origin all the way around our circle. So if we start to step through each point, like so, you see the crosshairs start to move. It's not moving much as the cosine wave begins to step into each of its plotted value at each radian. So I'll show you that too. I did 100 points, I believe. So each of these steps is 1/100th of 2 pi. So it's slowly changing, which is what we would expect for a circle that's going up and around this way counterclockwise to do. And the sine value is changing rapidly. So each time we jump one position of the cosine wave and the sine wave, and then take the intersection of the vertical point at our transposed cosine wave and the horizontal at our sine wave, this is where this will be a point on our circle. We'll just go all the way around here. See how we're starting to draw this circle, and it follows each of those points. So at this point, we're right here, draw a vertical line up, and we're right here, draw a horizontal line. That's the point on the circle. We'll keep going. Right here, we're at pi radian. So we're halfway through the cosine wave, which would be at our very most negative if you were to be looking at this point here on a standard cosine wave. Since we've transposed it, and we're making it represent on our chart the x values, it's all the way at the most negative x value. And we're at 0 on our sine wave, which we would expect. So let's keep on going. And we see we're going through the third quadrant and then coming back up through the fourth. And we will have completed an entire circle now. So let's go ahead and turn back on or turn on in the first place our circle. And those gray points there are the crosshairs, the vertical and horizontal crosshair point on our circle that's made up by using these x and y points off of each wave at each of the 1/100th radians or 1/100th 2 pi radian steps. So look how we traverse all the way around that again. That's what you can always do to remember how using that sine wave or the cosine wave that's typically plotted as a value with respect to radians or time. It doesn't make sense to how that can represent the x, but if you transpose it and turn it just like I've done here, you can see we can draw our circle just by stepping through the corresponding pairs of points one by one, and we'll draw the whole thing. Here's that same circle. If I hadn't shifted everything back to the 0, then our origin would have been right here at this 3.14 at where my cursor's at there, and our circle would have been over here out in space. But this, by transposing it again, it makes it easier to see how it actually represents the x values of the circle. So let's take one more look as we step through. Our crosshairs on each of those dots in space, where if you were to go back and look at the video I made on how to chart a circle in Excel, you'll see that this is the exact same relationship of just the cosine of the radians and the sine of the radians times the amplitude, which our amplitude is 3.14. So there you have it. The cosine wave makes up the x coordinates and the x point of a coordinate, and the sine wave makes up the y coordinate of a circle. So that's it there. If you have any questions, feel free to comment, like, and subscribe. Also, send me something and I can make this better. I can add some more information. I'm hoping this helps answer some of the questions I've received about why this works. So anyway, thanks for watching, and look out for more videos. Thank you.